X equals 1 plus x to the 2/3 power. Which of the following is not true?
Okay, let's start by graphing this. I know some of you guys are thinking, how do I know how to graph the one with the power with the fraction, right? Here's a generic rule. If you have x to the power of any even over odd, the behavior is always in this manner. In this manner. So if you're like, maybe test it on Desmos, you can. But right now, since I'm recording, let's not worry about testing it yet, okay? All right, so from here, now we have a y-intercept of 1, correct? So I'm going to go ahead and draw this a little more accurately. So here I have at 1. So we have a vertical shift of going up. So it's going to go up 1. And then the graph is actually going to do something like this. So it says which one is not true. Isn't this continuous? Can I draw this graph without picking up my pencil? Yes. It is continuous. It has a minimum at x equals 0. Do we agree on that? Okay. And f is increasing when x is greater than 0. So let me highlight that piece. To the right, it's increasing, correct? So we know that's also true. Let's put check. And then it says f prime exists for all x. So because we're looking at f prime, we have to go ahead and derive. Let's do that on the side over here. So we have f prime is equal to, would y'all agree my coefficient is 2/3? Yes. And then we have x to the power of negative 1/3, correct? Yes. So then if I were to rewrite this without a negative power, it's going to look like 2 all over 3 cube root of x. So let's see if this exists everywhere. What do I know about x being on the bottom? It is undefined at what? 0. So let's write it is undefined at x equals 0. That makes statement number D not true, which has to be the answer, but I want to further go on to the next part. Okay, on this one, we're looking at not single prime, but what? Double prime. So let's derive this one more time. So f double prime. So when I multiply the power and the coefficient, it's negative 2 over 9, x to the negative 4 over 3. And if I were to further simplify this, it's going to give me negative 2 all over 9 cube root of x to the power 4. And we are testing all the values of x greater than 0. So we know no matter what number I plug in, it's going to be positive. So negative divided by any positive is what? Negative. Is that statement true? No. It is negative. That's true. So we know the answer has to be D. Now let's go on to number 6. Okay, Jackson, let's read number 6. And this one, go ahead and open up Desmos while Jackson's reading. Go.
The derivative of f is given by f prime of x equals d3x minus 3x squared. At which of the following values of x does f have a relative maximum value?
Okay, I'm going to highlight relative maximum. And going back to your flashcard, make sure you're looking at it. The original function has a relative maximum when f prime is going from what? Positive to negative. And notice the graph I gave you was the f prime. So let's go on to our Desmos. I want you all to type in the given f prime. And we have e to the power of x. And then we have, I'm going to go to the right, minus. Y'all can type yours faster. Lucky you. All right, do we have what I have? Yes. Now we're going from positive to negative. So we know the first point right here, that's not positive to negative. That's negative to what? So that means that point is relative minimum. This point right here on the right, that's going to be relative what? Maximum. So let's talk about rounding. We need 3 decimal places. So 0.910. Do we agree on that? Yes. Now look at your paper. Which one agrees with that answer? C. Done.